Hi everyone. So I've been working on some robotics projects for a while now, and I thought it was time that I should make a video and sort of talk about what I've been doing. And yeah, so I had this problem earlier, past couple days, where I have a robot arm, and it is jerking around a lot. So for example, you can see here. So you can see how it goes into some sort of random orientation, and then it's going to overcorrect, and then sort of have to go back, and it causes all this problems. So what I found was the solution is let me just change this. Um, is to basically just do the sort of interpolation type thing that is able to get you a lot smoother motion. And I will show you how exactly that is accomplished in a second. Basically, you take the sort of starting angles and the final angles that you want, and you sort of interpolate through in a linear way. And we can quit that. So just to go through it real quick, so what we're going to start with is all the standard pi bullet stuff. Plane, get your arm, and then we're going to get a final and position and orientation, and we're going to get that through this random position and orientation function that I wrote. That's not particularly interesting, but you can see it. The code is linked down below. And then we're going to use inverse kinematics to get the final angles that we want, because obviously we want to think in terms of Cartesian coordinates and quaternions for position and orientation, but unfortunately the arm, as you saw earlier, is only able to move in sort of this angle space. That it only has it can only change the rotation of each of its joints. So that's where inverse kinematics comes in. Honestly, I don't really know the details of it, but I mean, it works. So then we're going to get this target angles, which is the angle approximation. So target angles and final angles are going to be different. Final angles is just going to be a list of 7 numbers that we want are to be at the by the end of it, all of our joints should be at those angles. Target angles is a giant NumPy array. It's 1,000 by 7. So we're going to interpolate between the starting angles and the final angles, and each of those target angles are that target angle array is going to be all of the angles that we get in our in between sort of angles. So this is what it actually looks like. We have the KUKA ID, which is the arm, the ID for the arm, the final angles they want, and then by default k, the number of iterations is 1,000. We have the starting. We're going to initialize our starting angles. We're going to go through each of the joint states and just sort of get the starting angles so we know what we're starting with. We're going to turn them all into NumPy arrays. Then we're going to initialize the target angles as a array of zeros, and that's where the 1,000 by 7 array part comes in. We're going to begin our target angles with the first row is going to be our starting angles, because obviously that's where we start with. And then we're going to go iterate through each of the target angles, and then it's going to be the starting angles plus the difference, so that's the distance that we want it to go, times I divided by k. So basically this is just going to give you, so you go 1/1000th of the way to your final angle, then you go another 1/1000th, and so on and so on. You can pretty easily just take a pen and a piece of paper and just sort of convince yourself that this is true, and you just need to do it with honestly just one angle, and it's true for all of them. So yeah, and then it's going to return our target angles. Then it's going to we use the set motor control array to set all of the joints that we want to the target angles that we want at the particular time step that we have. And then we're just going to advance it just 2 steps. It should be pretty short. You can turn this up if you want, but it's not really going to get you any more, especially when you're sort of dealing with relatively small angles and large iterations. You only really need 1 or 2 steps. Yeah, that's pretty much it. Hopefully in the next video you'll see what this is actually being used for, and why it matters. And I will put that up as soon as that is done. So yeah, that's it.